Every interval you have learned so far fits inside a single octave, from a tiny second all the way up to the octave itself. Second, third, fourth, fifth, sixth, seventh, octave. 7 steps, and then you are back where you started, an octave higher. But notes do not have to stay that close. A bass player can hold a low note while a singer floats a melody way above it, and the gap between them can be much larger than 1 octave. 2 notes can sit further apart than an octave, and when they do, something neat happens to their names. The counting does not start over. It just keeps climbing. A second above the octave is not called a second anymore. It has a bigger number, and that bigger number tells you something the small one cannot. It tells you the top note is not just a step away, it is a step away and an octave higher, which is a very different sound. So today we go past the 12th fret, past the top of the octave, into the world of compound intervals, the ones that earn the chord names you see in jazz and pop charts. Here is the thing that trips people up, and it is why a single octave keyboard is the wrong tool for this. Picture a low C at the bottom, and the note D sitting more than an octave above it. On 1 octave you would have to cram that high D right next to its low neighbor, which is a lie, because the real D is way up the keyboard. The picture would tell you either notes are touching when in truth they are far apart. So we use 2 full octaves, side by side, and we put both notes where they truly live. The low C down here, and the high D up there, more than 12 keys higher. Now the picture matches the sound, the further right a key sits, the higher it really is. Played together, those 2 notes are not a second apart. They are a 9th. Count it through if you like. C up to the next C is an octave, that is 8, and then 1 more step to D makes 9. Listen to how wide and open that 9th sounds compared to 2 notes squashed right next to each other. The same 2 letters, C and D, but a world away in feeling. The rule for naming these is simple addition. Take the plain interval inside 1 octave, the simple interval, and add 7. That is it. Why 7 and not 8? Because the octave itself is counted as an 8, and the 2 notes share that octave step, so you do not count it twice. The shortcut is just add 7 to the simple number. A second, lifted an octave, becomes a 9th. A third becomes a 10th. A fourth becomes an 11th. And a 6th becomes a 13th. Watch each one stretch across the 2 octaves and hear it. Here is the 9th again, a second plus 7. Now the 10th, a third plus 7. Now the 11th, a fourth plus 7. And finally the 13th, a 6th plus 7. Every one of them is just its smaller cousin carried up a full octave, with 7 added to the number. Notice we stopped at 13 and did not keep going to 14 or 15. In practice the 9th, 11th, and 13th are the ones that matter because they are the notes a chord actually reaches for, and we will see why in a moment. The sound gets airier each time as the top note climbs further from the bottom. Naming is one direction. You can also go the other way and shrink a compound interval back down. This is called reducing it, and it is the move that lets you check your work. To reduce a compound interval, you drop the top note 1 octave, which means you subtract 7 from the number. A 13th, brought down an octave, is really just a 6th. An 11th folds back into a 4th. A 9th folds back into a 2nd. Watch the top note fall an octave and land right next to its partner. The 13th becomes a 6th, the same 2 letters, now sitting close. So a 13th and a 6th are the same pair of notes wearing different clothes. One is spread out across registers, the other is packed tight. This is genuinely useful, because if a big number ever confuses you, you can always fold it back down to a simple interval you already recognize, name that, and then add 7 again to get back. Same letters, different distance. If the notes are really the same letters, you might ask why the bigger name matters at all. Why not just call everything a 2nd or a 6th and be done? Here is why. The compound name tells you the note is up in a higher register, spread out, not crammed against its neighbor. And that spacing genuinely changes how a chord sounds. A second sitting right next to the root sounds tight and a little clashy. Two keys next to each other grind against one another, and the ear hears tension. But lift that same note up an octave to make a ninth, and suddenly it sounds open and lush, with room to breathe between the notes. The grind is gone, and what is left is color. Same two letters, completely different color, and the only thing that changed was the octave of spacing. This is why a composer bothers to write a ninth instead of a second. The bigger number is the composer telling you the spread out, brighter version is the one they want, not the tight, clashing one. This is exactly where compound intervals earn their keep, in chord extensions. You already know a basic chord, a triad, is a root with a third and a fifth stacked on top. Extensions are what you get when you keep stacking past the fifth up into the compound numbers. When you see a chord written as add 9 or an 11th chord or a 13th chord, those numbers are compound intervals stacked on top of an ordinary triad. The triad gives you the foundation, and the 9th, 11th, or 13th on top adds the color. Listen to a plain triad first, just root, third, and fifth. Solid, but a little plain. Now add a 9th on top, up in the higher octave, and hear the chord open out and shimmer. That single extra note is doing all the work, and it is a compound interval. Jazz players voice chords exactly this way, deliberately spreading the notes across 2 or 3 octaves so the extensions ring clear above the core of the chord. A piano player will often put the root and a guide tone low in the left hand, and float the 9th and 13th high in the right, precisely so those colors sing out on top. The compound interval is the reason those voicings sound so rich. So how do you find and name one yourself, on the spot? It is a two-step move, and it never fails. First, ignore the octave and name the simple interval, the way you already know how, counting the letters from the bottom note up. So if you have a low C and a high E, you ignore how far apart they sit and just notice that C to E is a third. Then ask one question, is the top note more than an octave above the bottom one? If it is not, you are done, it is just the simple interval. But if the top note really is more than a full octave up, add 7, and use the compound name. That low C to a high E more than an octave up is a third plus 7, which is a 10th. Name the simple interval, check the octave, add 7 if it cleared the octave. That is the whole method, and it works for any pair of notes you meet, on any instrument, in any key. So past the octave, intervals do not stop or reset. They keep counting upward, and those higher numbers, the 9th, the 11th, the 13th, are the language of richer, more spread out chords. You now know how to name one by adding 7, how to fold it back down by subtracting 7, and why a composer would reach for the wider spacing in the first place, for the open, breathing color it gives. The next time you see a chart with an add 9 or a 13th on it, you will know exactly what those numbers are asking for. Next we follow these compound intervals straight into the chords that are built from them, the extended chords, where add 9, 11th, and 13th voicings give pop and jazz their lush, open sound.